All right, welcome back, 8th graders, to another edition of The Explainer. I am so pumped to have you here today because we're taking on a totally new, absolutely crucial role. Today, you're stepping into the shoes of a data detective. Look, we live in a world literally overflowing with information, numbers, statistics. It's like a giant puzzle out there. But how do we actually read those clues without jumping to completely false conclusions? How do we separate fact from fiction? Well, grab your magnifying glasses, because that's exactly what we're going to figure out today.
Let's just dive right in with a kind of ridiculous question. Do more swimming pool visits cause the weather to get hotter? I mean, think about it for a second. Every time the local pool is packed with people, it's scorching hot outside, so the pool itself must be generating the heat, right? No way, obviously not. But, this funny little example hits the nail on the head. It instantly shows the huge danger of making false assumptions from data. Our brains are hardwired to look for patterns, but as data detectives, we got to be way smarter than our first instincts.
To guide us, we've got our big idea for the day, beautifully captured in Ecclesiastes chapter 4, verse 9. Two are better than one, because they have a good return for their labor. Now, what does this have to do with data? Literally everything. When we look at just one single piece of information, we're basically blind. But when we look at two things, whether we're comparing two groups or tracking two different variables, we get a much clearer picture of the truth. Two data points working together give us a far better return for our investigative labor.
Okay, let's pull out our detective toolkit for section 1, comparative versus correlative.
So, these are basically the two primary magnifying glasses we'll use to look at evidence. First, we have comparative, which measures the exact differences between specific groups, and then we have correlative, which looks for relationships between variables as they naturally happen. Knowing exactly when to use each one is absolutely critical. Honestly, mixing them up is exactly how people, yes, even adults and professional scientists, make some pretty embarrassing mistakes. This skill isn't just for math class, you guys. It's crucial in science, health, business, and even just your everyday decision-making. If you don't know the difference between comparing and correlating, you're going to get fooled by bad data.
Let's pick up that first magnifying glass. A comparative study measures and compares two or more groups, and this usually happens through a controlled test. Imagine you're actively testing something out. You aren't just sitting back, relaxing, and watching the world go by. No, you're setting up a specific scenario. You have Group A and Group B, and you are changing exactly one single thing to see what happens. You're completely in control of the whole shebang.
And this brilliantly illustrates exactly what I mean. Think about comparing plant heights. The question we're asking is, which soil type produces taller plants? Well, we take two identical seeds, give them the exact same amount of water and sunlight, but we plant one in soil A and the other in soil B. This directly compares plant height across two distinct groups. Because we actually controlled the test, we made sure everything else was identical, we can confidently say, yep, soil B is definitively better for these plants. Right, so now let's switch to our other magnifying glass, the correlative study. Unlike those controlled comparative tests, a correlative study looks for patterns in how two variables change together based purely on observed relationships. In this case, you aren't controlling anything at all. No laboratory, no special equipment, you're just a detective looking out the window, jotting down notes, and noticing that, hey, when thing A happens, thing B also seems to happen. For example, think about this observation. As temperatures rise, ice cream sales and swimming pool visits also rise. They're moving together. There's a strong relationship there, a correlation for sure. But, does eating an ice cream cone magically teleport you to a swimming pool? No, of course not. Both of those variables relate to the summer heat, but one does not cause the other. They are simply correlated.
And that brings us right into section 2, the causation trap.
So this trap is pretty much the most common, most dangerous mistake in data analysis. It's when a detective looks at a correlation and falsely claims they've actually found a cause. For instance, does eating breakfast equal better grades? We hear this claim literally all the time, right? Eat your breakfast, it'll cause you to get A's. And sure enough, if you look at the raw data, students who eat breakfast often do have higher test scores. But hold on a second. Put those detective hats back on. Is this a controlled comparative test or just an observed correlation? It's just an observation, which means we might be falling headfirst right into the causation trap.
Let's break down this little illusion by looking at some hidden factors. You see, students who eat breakfast might also just be students who get more sleep. Or maybe they have a super supportive home environment with parents who wake them up early, make breakfast, and make sure they studied the night before. Actually, it might not be the pancakes causing the good grades at all. It could totally be these hidden factors influencing both the morning routine and the straight A report card.
So the absolutely crucial point here is this golden rule. Just because two things happen together does not mean one causes the other. Let me say that again. Correlation does not equal causation. Honestly, if you take nothing else away from this explainer, remember that. Whenever you see a wild headline or some crazy statistic online, you've got to pause and ask yourself, wait, is this a carefully controlled comparative test, or is there some hidden factor pulling the strings behind these results?
All right, time to switch gears. Section 3, test your knowledge.
Now that you've got the tools, it's time to prove you can spot the difference out in the wild for part 1 of your homework. First up, you need to provide your very own example of a comparative study. Remember, think of a controlled test where you pull the levers. Next, give an example of a correlative study, something you just observe happening together out in the real world. And third, explain in your own words why correlation does not prove causation. And hey, don't just repeat the rule. I want you to really explain why it's such a massive trap. And to finish off the assignment, step 4. I want you to describe a hidden factor that could affect both variables in that correlative study you came up with a second ago. Finally, step 5, put on your virtual lab coat and explain how you would design a fair, comparative test between two different sports drinks. How would you make absolutely sure you're comparing them fairly without any hidden tricks or biases creeping in? I seriously can't wait to see what you guys come up with.
Okay, let's slow things down just a bit and move to our final section, wisdom and morality.
We've spent a lot of time sharpening your intellectual tools today. But here at Heroes Smart Academy, we truly believe you need something deeper. Romans chapter 8, verses 6 and 7 promises peace of mind to everyone who keeps their mind spiritual. Just think about that for a second. Being a brilliant data detective is fantastic, but having a spiritual mind is what actually brings real peace. If your mind is only filled with cold numbers and raw data, but it lacks that spiritual grounding, you're going to find yourself feeling pretty anxious and lost, no matter how smart you are.
And this brings us to the absolute core of the Godly Learners series philosophy. It's this: education without morality will hurt. We intentionally intertwine biblical morality with education because, well, we know that giving you powerful intellectual tools without giving you a moral compass to guide them is actually dangerous. If you don't know right from wrong, all that top-tier education will eventually just lead to hurtful, destructive choices.
So, I'll leave you with this final, really important question. What's the point of being super smart and highly educated if you just continue to make bad choices that hurt yourself and the people around you? True education, it isn't just about reading charts or memorizing what correlative data is. It's about taking that knowledge and using it with wisdom, with morality, and with a spiritual mind to make the world an actually better place. So as you finish up your detective work today, ask yourself, what kind of detective do you really want to be?